M1L24 is called multiplying and dividing rational expressions. So in other words, we're going to multiply fractions. So when we take a look at this particular piece, just as a reminder, whenever you multiply fractions, we multiply from left to right, and that would give us AC. And then we multiply from left to right for the denominator, and then that would give us BD. Sometimes we want to look for whether we can simplify things or not ahead of time, and that makes the problem easier, depending on what it is. So we're just going to go through a series of examples and exercises, half of them that shows how to multiply of various levels of difficulty, and then we'll do some division to show those levels of difficulty as well. So in example number 1, they give us this piece right here. I'm going to drag it down here. And it says x to the third times y squared in the numerator. So if we were to do that, multiply from left to right, that means I'm going to get x to the third times y squared. And then when I multiply from left to right in the denominator, I'm going to get 4xy. I always write my alphabets in alphabetical order, and so I need to simplify. And so it turns out, since these are all products and there's no adding and subtracting, I can start canceling. So 3 minus 1, I get x squared left over in the top. And then 2 minus 1, I get a single y left over in the top, and a 4 at the bottom. Now, for those people who are very visual, if I was to write this out, right, so we'll just kind of draw a little arrow down here. I would write x times x times x times y divided by 4 times x times y. So that allows me to cancel an x for an x and a y for a y. That is why my answer ends up being x squared, because I got 2 x's and a single y left over and a 4 at the bottom. So again, to recap, all we did was multiply from left to right and then simplified. So let's look at one a little bit more complicated. So this one has a whole bunch of expressions in it. It seems like each one of them has its own respective greatest common factor. So one of the things that we'll do is we'll find the GCF for each one. So the greatest common factor of this numerator is a 3, and that is going to remain with an x minus a 2. The denominator, the greatest common factor is a 2, so we end up with an x plus a 3. The numerator's greatest common factor is a 5, so this is an x plus a 3. And then the denominator is a 2, and so not a 2 but a 4. And then we end up with an x plus a 2 in our final answer here, plus 2. And so then what we're going to do is we're just going to simplify everything out that we can. It turns out that this one can cross cancel with this one, and I think that may be about it. So now that we can't cancel anything else, we're going to multiply from left to right. 3 times 5 is 15. We have an x minus 2. And then 2 times 4 is 8. And we have an x plus 2 left over. This will be our final answer. You don't have to distribute these back in. It is perfectly acceptable to just leave the answer the way that it is. So we're not going to do exercise number 1 where it says summarize what it is you learned so far with your neighbor, for the video anyway. And so let's look at number 2. Find the following product and reduce the lowest term. So we're going to do the same thing that we just did. We're going to factor everything that we can factor. So this one right here, there's a greatest common factor of a 2. And so we have an x plus a 3 left over. The denominator, we could split the x's up and we're going to get a plus 3 and a minus 2. That is going to be multiplied to this one, which is a difference of squares. X minus 2, x plus 2, and this is over 2 times x. So once I've done that, I'm going to cancel anything that's in the numerator and the denominator that's shared. So like this one and this one can go away. This 2 and this 2 can cancel. And this plus x plus 3 and this x plus 3 can cancel. So the only thing left over in my answer is x plus 2 in the numerator over x. Let's see. For the next one, they give us this interesting little thing. Let me make this little note. This little negative 2 right here. We don't like it to be negative. Now, this does come up from time to time. The way that we fix that and address that is you basically take your fraction and you flip it over. So I'm going to take this 3m plus 6. I'm going to put it in the numerator. I'm going to put that 4n minus 12, put it in the denominator. And what that does is that simply turns that negative 2 into a positive 2. Now, you want to do that because in a minute you're going to realize how valuable that is. We really don't want a negative exponent if we can help it. And so now that we've done that initial step, now we're going to factor everything. So the numerator here, I could pull a 3 out, and I have an m plus 2. In the denominator, I got to pull a 4 out and have an n minus a 3. Now remember, all of that is still in the squared. So the other fraction, right, this could be n, let's make a little bit more room there. Let's see. Let's just slide all of that over. No, I didn't catch it. Let's slide all that over. And so the numerator here is going to be n and n, and then a minus 3 and a plus 1. And then my denominator is going to be an m and an m, and with a plus 2 and a plus 2. Now, here's the next interesting little trick. Because all of this is a product, this one is multiplied to this one, and this one is multiplied to this one, I can now distribute this exponent of 2 to everything. So now I end up with 3 squared, which is 9. I end up with 2 m plus 2's. 4 squared is 16. And I end up with 2 n minus 3's. That is multiplied to n minus 3 times n plus 1 over m plus 2 m plus 2. So now we're just going to cancel anything that's on top and bottom. So this m plus 2 cancels with this one. This m plus 2 here cancels with this one. This n minus 3 cancels with one of the ones down here. And that, I think, is all we can cancel. So my final answer is 9 times n plus 1 over 16 n minus 3. So that is, I think that's all the multiplying. That switches us to division. So division essentially works the same as, as multiplying, except remember, we don't actually divide fractions. If we divide fractions, we flip the second fraction and multiply. So that could be seen up here in the top, where originally we had a over b divided by c over d. Since we don't actually divide, what we do is you leave the a over b alone, you change it to multiplication, and you flip the second fraction over. And then at that point you follow the same multiplication rules that we did in the past. So what I'll do is I'll model a couple of those. I think there's 3 of them. And so we have this piece here. We don't actually want to divide fractions, so we rewrite this as x squared minus 4 over 3x. We change it to multiplication. We write 2x over x minus 2, and then we're going to multiply. So this is my difference of squares. So we write x minus 2, x plus 2. This is 3 times x. Let's write that a little bit nicer. 3 times x. We multiply that by 2 times x over x minus 2. So this one and this one cancel, and these x's here cancel. So my final answer is 2 times x plus 2 over 3. For exercise 4, same idea. Remember, we're going to keep this one as is. We're going to change this to a multiply, and then we're going to flip this. Now, but this time, what I'm going to do to save a little bit of writing is I'm going to do that as I go. So I already know that I need to factor the numerator of my first fraction. So I put an x and an x. We're going to have a minus 3 and a minus 2. That's going to be over x plus 4. Now I know I need to change my division to multiplication. So when I write this, I'm going to flip this as I factor. So this difference of squares is going to go to the denominator. So I have an x minus 3 and an x plus 3. My denominator is going to go to the numerator. And so I'm going to write x, and this will be plus 4 and plus 1. So now I can see what I can cancel. This x minus 3 can cancel with this x minus 3. This x plus 4 can cancel with this x plus 4. And so then my final answer is x minus 2 times x plus 1, and that's going to be over x plus 3. So that's exercise number 4. The last one we have is this one here, where it's written in the style of a complex fraction. So again, we don't actually divide fractions, so what we're going to do is we're going to rewrite this as a multiplication. Here we go. And so we're going to factor this as we go. And so we're going to have our x plus 2. We are going to factor our denominator. So we put an x here and an x here. This will be a minus 3 and a plus 1. Now remember, this fraction bar right here means divide. We don't actually want to divide. So we're going to change it to multiplication. And as we're changing to multiplication, we are going to move this one to the numerator. So we put an x and an x. Something that multiplies equal 5. So we have a plus 5 and a plus 1. This one's going to go to the denominator. So we factor this one open with an x and an x. So that become a negative 3 and a plus 2. So now that we have that, we're going to see what we can cancel. This x plus 2 cancels with this x plus 2. This x plus 1 cancels with this x plus 1. And so my final answer is going to be x plus 5 over x minus 3 squared. You could write the x minus 3 twice, or you just write it with a squared on it, and then that's our final answer. So that is the end of lesson 24.